Imagine building an AI assistant that doesn't just chat, but actually remembers your conversations, searches through your company's documents, and takes real actions in your business systems. That's LangChain. And if you don't know it yet, you're already behind in the AI job market. LangChain is a powerful framework designed to simplify working with AI models like OpenAI, Google Gemini, or AWS Bedrock. It allows you to build intelligent applications by connecting AI to external tools, databases, and documents. And interviewers are asking about LangChain in most AI-related roles. So if you're applying for positions like AI engineer, data scientist, or cloud AI specialist, this video is a must-watch for you. In this video, we will dive into the essential concepts of LangChain, covering what LangChain is, its key components, LangChain chat models, and prompt templates. We'll show you how LangChain helps you structure AI outputs, build smarter agents, and effectively manage memory across conversations. And by the end of this video, you will see why LangChain is essential for anyone working with AI and why it's such a key skill in job interviews. Also, this video is just a part of what's covered in our AI/ML track program, through which professionals like Debashish, Roshan, and many have landed high-paying jobs and certifications in the field of AI. And if you want to move a step ahead and learn more for high-paying jobs, we are hosting a free 90-minute masterclass on AI/ML, GenAI, data science, and Agentic AI, where our experts will share a proven 3-step framework to help you land your dream jobs. So don't miss out. Register now through the link in the description below. So now let's dive into the video.
And now via LangChain, you just change the name of the model. It's like plug and play. Just change the name of the model and done. So that is the main thing. Apart from that, we have other things like we can attach memory, we can attach multiple steps, we can attach prompt templates, which has variables. So, and again, you can have output parsers. So let's say the LangChain will be able to structure the output in a specific format. So the output which came from your model was very raw. That was not structured. Let's assume that the output coming from the model is not structured, but LangChain can structure it in the way that you want it. So we have output parsers also. So a lot of these things are there. Let's see one by one. So it's an open framework to develop applications. So now we are getting into the application development. Right now we were accessing the models in a very, very raw, crude format. Now we want to start developing the applications, more sensible operations we want to do, right? So core framework relies heavily on the libraries. So behind the scene, it is still using the OpenAI library, generative AI library, or whatever libraries coming from these model providers. So multiple steps can be chained and more complex tasks can be performed in a more conversational format. So the entire RAG systems, agents, we can create agents using LangChain and so on. Okay, even agents can be built. So that also we will see. So LangChain is your main framework for this entire course going forward. Okay, you have to get extreme comfort on this package framework. Okay. The good thing is now LangChain comes as an ecosystem, like Python is the ecosystem. From Python, you have NumPy, Pandas, scikit-learn for model building, TensorFlow and PyTorch for deep learning, okay, LangChain for generative AI. So that is the Python ecosystem. So now what I'm saying is LangChain itself is another ecosystem within a main ecosystem of Python, which comes with observability and traceability tools, including deployment. So whatever application that you are going to develop using LangChain, let's say you created a RAG system in LangChain. That's your application. Or you wanted to create an agent in LangChain. That's the end application. Now that application can be deployed, monitored, and tracked by using these additional services. So how does LangChain make money? LangChain makes money because of these services. LangServe and LangSmith. Okay, these services are not available for free. That is where the LangChain guys are making money. So for experimentation, it is free, but the moment you start deploying these applications in real-time production environment, okay, the billing starts. Good to experiment and learn, but for production cases, these guys will start pinging you for money. So that's where, so LangChain has given everything for you to learn, study, experiment. But the moment it starts going enterprise way, that's where the LangServe, LangSmith, LangFuse is another one. Okay, LangFuse and LangGraph. LangGraph will be using for creating more advanced complex agents. What do you mean by complex agents? Like multi-agentic system, multi-agent system. So LangChain will give you basic agents, one workflow. But if you want to tie up 10 workflows together, orchestrate 10 workflows, you need an orchestrator agent and small worker agents. So that kind of complex workflows can be done using LangGraph. So LangGraph is also a part of the LangChain ecosystem only ultimately, right? So that's exactly what I explained. So this is a snapshot coming from the LangChain main page, okay? And you can see the LangChain core is there, model IO. So these are the different components, okay? I'll talk about these components one by one now. So one component is the LLM. So what is this? This is where you will directly access the model and do zero shot, access to the LLMs and you get the response. Direct access to the model. LLM component is the direct access to the model. Okay. And whatever we are doing right now using, let's say, Hugging Face, the same thing you have replaced it. See, Hugging Face is right now acting as a connector between your Python code and the model, right? Now the same model will be connected by using LangChain. We are going to get rid of Hugging Face now, right? So that component is called as the LLM. Prompt templates. So we'll have elaborate prompt templates, and that's where we will venture into our prompt engineering, chain of thought, tree of thought, and then persona pattern, flipped. So all these different prompt design templates will be able to use within LangChain very effectively. Agents, as I just now mentioned, will be able to create RAG systems in LangChain. Memory. So what does that mean? You have made multiple conversations with the LLM, but problem is the LLM doesn't know about your previous conversations because each call to the LLM is stateless. So what was the previous conversation? How to keep a track? So LangChain gives you a memory module for tracking the previous conversations, tracking and storing as a context. So you can store all the previous conversation and pass it to the LLM as an additional context. Okay. So that way the LLM knows, acha, so this guy has already asked so many questions. Okay. And these were the responses to the previous questions. So now I should be answering this. So for example, the first question is, what is United Nations organization? So it will give you now. When was it formed? See, the subsequent question was, when was it formed? So how does the model get to know? What does it refer to? That is only possible when you have memory implemented in the conversations. And then callbacks. I will discuss about the callbacks, but giving a high level idea about callbacks right now will not make sense. So yeah, these are different ways. So for example, you can access the OpenAI models in LangChain. You can access the GenAI models from Google. So these are what? These are additional packages created by LangChain as a wrapper. So if you see, what I'm trying to say is this. You access the OpenAI models directly. You remember, you access the OpenAI models using the OpenAI. Now you are saying that LangChain has wrapped that entire OpenAI package in its own version. So that's what I said. You have the model, and LangChain has given you a wrapper over that model. So if this model is coming from OpenAI, the wrapper is called as LangChain OpenAI. If this model is Gemini model, the wrapper name is Google GenAI. If this model is coming from Bedrock, then the the wrapper is called as AWS. If this is coming from Google Gemini, that is the Vertex AI again coming from Google, and so on. So if your model is your Anthropic model means Claude, Sonnet, Claude, Opus, Claude, Haiku. These are the three model names coming from Anthropic. Then this wrapper will be called as LangChain Anthropic. So do we have to pass API key? Obviously. But these are direct API keys. not Hugging Face keys, direct API key from OpenAI, direct API key from Vertex or Google or AWS or Anthropic. Yeah. So LangChain will have a mechanism to pass that API key to the model vendors. So this is not open source, and we are not. So also LangChain, via LangChain, you can access the open source model. But that example I'm not going to take because again, it's just the repetition of what the Hugging Face has already done for us. Okay. So let me repeat it once again. The LangChain community is where it's a one-stop solution to connect with all open source models. This is going to replicate the Hugging Face functionality. This is not what we are going to discuss. We'll not invest time in that. We'll mostly invest time here. Okay, because this is exactly the same as what we have just been doing in the last few days, using Hugging Face, accessing those models. Okay, LangChain also has an interface to access those models via Hugging Face. So it's now like that. So you have the model, then over it you have the Hugging Face, over it you have the LangChain. You see, so LangChain is a wrapper over Hugging Face, which is a wrapper over the actual model. So right now we are directly accessing via Hugging Face. Now even that Hugging Face has been wrapped. Why? Because even the Hugging Face codes can be daunting. You see, even the Hugging Face codes can be complicated. Is it not? Auto tokenizer, auto model, and all that. That's what we saw right now, right? Even these models, if you want to access it without pipeline, the codes are very tedious. These codes are very tedious. Do you agree with me? These codes are tedious. So what did LangChain do? LangChain says that let me even wrap this into one line. LangChain says let me wrap this into one line. Is that now clear? So that is what it says here. Okay. Now LangChain also has a mechanism to connect with vector databases like Pinecone, VV8, Milvus, ChromaDB, Fies, a number of vector databases are that we are going to use in our RAG systems. Right? Oh, sorry. Okay, so this is the first thing that we are going to take: model input output, LLM input output. So basically, we'll create a chain in which we are going to pass the model name and the prompt. Okay, so the main takeaway from this is a snapshot from the LangChain documentation only. So, but the main understanding is, listen to me carefully, you can interact with the model directly using two mechanisms, the LLM or the chat model API. So these are two APIs, two endpoints you can say, being exposed by LangChain. You can use the LLM endpoint or you can use the chat model endpoint. Advantage, disadvantage. So LLM endpoint takes only instruct models like zero shot. Okay, what is the capital of France? You are not interested in the conversation. If you're interested in the conversation, you use the chat model. Advantage of chat model is you will be able to use conversational fine-tuned models. Okay, okay. GPT 3.5 Turbo is an instruct model, whereas GPT 3.5 Turbo oh, the other way around. Instruct, and this is only Turbo, right? Sorry. Where is that gone? Okay, so this GPT 3.5 comes in two variants. GPT 3.5 comes in two variants. Okay, the instruct variant and the chat model variant. Okay, the instruct variant will use the LLM API and a normal chat model API. I mean, if you want to get a conversation, if you want to do a conversation with GPT 3.5, it will use the chat model, or you should use the chat model API. The advantage is that it also remembers the previous conversations. So this API remembers the previous conversations somehow. Okay, not because of the model, it is because of the LangChain's code. LangChain has written it in a way that the previous conversations being made in the same session are also remembered. Okay, but in LLM endpoint, each conversation that you are making with the model is one single transaction. That's it. I mean, no previous memory would be present. Okay, so it's zero shot direct conversations which are going to happen. So for simple tasks, you can use the LLM endpoint, which is very fast. Okay, but and the models are instruct models. There are models which are chat models. So see, even every vendor will have instruct models and chat models. You need to know that somehow. Again, that is where the experience comes in. Okay, so everything just cannot be obtained everywhere easily. So somehow you need the instructors to tell you that these are chat models, these are instruct models, or else you go through the documentation of each of these company pages and keep reading. So for example, in OpenAI models page, there's a huge listing, and from there you will get to know. But you will get to know only when you go inside each model, and each model also has its own documentation page. So when you look at the documentation page of each model, then you get to know whether this is a chart model or instruct model. Okay, if you want pure text completion jobs, like write down a story on generative AI, fine. You don't need any conversation. You are asking the model to perform a specific task. Give me an email asking for leave because of so and so reason. There is no conversation. There is no conversation needed. So it's a simple instruction given to the model for a completion job. That's what the LLM API endpoint is. Okay, and chat model, if you want the language model with different types of input output, you want to basically also produce the output in the form of a text, sorry, conversation, then you will use the chat models. So let me just skip here. Yeah, this is what. So the instruction following models, okay, which are completion style, they expect plain text prompts and direct completion instructions. Do this, write down a poem on so and so topic, write down an essay on this, write down an email asking for this. These are instructions clearly. Okay, when you want to engage in more discussions, okay, then you will use a chat optimized models which come in the messages format. So multi-turn dialogues. Why is the word multi-turn? Means it remembers the previous conversations. So each new conversation is one turn. So you have already asked 10 questions, so it's a 10 turn message now. It's like that. Okay, so these were initial instruct GPT family, and now they have been discontinued. So I'm going to use GPT 3.5 Turbo in my actual hands-on. And for the chat optimized model, you can still use GPT 3.5 Turbo. That is the base chat model coming from the GPT 3.5 family. And if you want a larger context, so this guy has got a 8,000 as the model context. But if you want 16,000 model context, then go with Turbo 16K or this GPT-4 model. Now, if you see all the later models, by default, they are chat models. So very few instruct models are now available. Very few instruct models are now available. Okay, because I mean they are not very useful, because even the chat models can do the same thing. Literally, the chat models can also do the same thing as the instruct models. So these model vendors have stopped making instruct models now. Okay, they are directly making the chat models because that is they have found as more useful for the end users. So all the GPT-4 GPT-4 is Omni. Multimodal models are Omni models. Text to image, image to text, text to speech, speech to text. These are multimodal. Okay, and then GPT 4.1 family, GPT-5 family, thinking, reasoning. These are all chat models ultimately. So what does that mean? This means that if you want to interface any of these, if you want to call any of these models in your project, you have to use the chat model API, not the LLM API. You have to use the chat model API, not the LLM API. So that's the main difference.
So the best thing about the chat model is it is very, very easy to implement the system prompt and the user prompt. I mean, I'm not saying that it cannot be done with the LLM API. It can be done. It's a bit tricky. And the way it gets implemented by different vendors is also very, very different. But for chat models, because they have to have the capability of, you know, taking system prompts and user prompts. So all the chat models do expose the system prompt and the user prompt very clearly. So if you see here, I'm just slightly zooming this. So, so this chat OpenAI, that is the chat model coming from OpenAI. Okay. So this is your chat GPT, which is the chat model ultimately. Okay. You just provide your model name. Okay. The instruct models will have a typical suffix like GPT 3.5 turbo instruct. So you'll have a proper instruct model mentioned at the end. So otherwise, it's mostly a chat model now. So most of the GPT-4 family models, they are all chat models. GPT-5 model, they are chat models. O3 model, O1 model, these are all chat models by now. Okay. Temperature, we have discussed that in enough detail in the previous sessions. So here now I've got my LLM ready. This is the user prompt. This is the system prompt. It's very clearly mentioned there. Okay, system prompt says that I want the LLM to act as a helpful assistant and give meaningful examples in the responses. This is what the user wants to know about generative AI in 3 bullet points. And then this messages is basically the payload that you are creating, and that payload is given directly to the ChatGPT.invoke method. So just remember the invoke method is the method by which we actually nudge the model to start producing the outputs. Until then, it's all just configuring the model. Okay, so this is all model config. Okay, in a way, you are just configuring how you want to call the model. The actual call takes place using the invoke function. Okay, so that is the actual function which actually calls the model. Fine. So once you have the response, you can actually print that response, whatever it is. Okay. So now you can see we have similar APIs. The way we connected with chat OpenAI, we have the chat model version for connecting with the Claude models. We have the chat model version for connecting with the Hugging Face models, for Gemini models, and so on. So all the most popular LLM and LLM providers, they are all supported with LangChain. Fine. Now, back to the discussion on messages. Here we had the messages. So there is a concept called as turn. Let's understand that turn. Okay. So messages are the fundamental unit of communication with these chat models. Okay. What does that mean? So these represent the input and output of one chat. So one communication. Okay. So this is a system message that you have given. Let's say this is the human message, which is the user prompt. And this is the AI message, which is the output coming from the model. Okay. So this is a system prompt, this is a user prompt, and this is the output which has got generated from the model. That is the meaning of AI message. So this entire thing becomes one turn. Okay. And then you have subsequent turn. So let's say I'm asking a follow-up question. Okay. So the first question was, what is United Nations organization? And I get the response, United Nations organization is a organization of 98 countries, this and that, with the headquarters located at Manhattan, founded in 19 whatever 45 and so on. Okay. Then I can ask, is India a member of it? Is India a member of it? So it should be able to understand that it is now referring to the United Nations organizations. Okay. So then it will tell, yeah, India is one of the 10 founding members of UNO and so on. Okay. So that is the AI message. So that is the second turn. So each of the, you know, conversations that you are having with the model is called as turn. Okay. Now, there is another way that you can combine all of these turns if you want to, get more context, more memory. Okay. So this tool message basically tries to combine the previous turns. So ultimately, each subsequent conversation will become an entire turn. So let's say you got another conversation here and the output. So this conversation and output will be again combined. So you'll get one big bunch of communication. So this way the model knows that I was initially asked this, I responded that, and then there was some message coming from the tool, then I responded that. There was another question coming from the user, I responded that. So all the previous context is very explicitly passed to the model. So all the conversations are still turn one. That is a big advantage uh, of providing an explicit context. But again, the second method will cost much more amount of tokens. Okay, because as the conversations keep on happening, you are appending it to the entire context window, and that entire message gets passed every other time. So the number of token usage will exponentially rise, right? However, in this case, this is one turn. So you will be charged for this much token as the input, and you will be charged for this much token as the output. So these two will be charged. You will not be charged for the turn one. Okay, when you are making the turn two. So similarly, when you are doing the turn three, it knows that turn one and turn two has happened. It will just take the input as turn three and reply that. So these things will become more clear. I mean, this is just a high level concept, but you will get to see these things when we start implementing memory. Okay. So you have the conversational buffer memory, conversational window memory, and then conversational buffer window memory, also summary memory. So there are three types of memory that you can attach to these models, okay, via LangChain. So all the three mechanisms we'll see later. The most important takeaway right now is basically the prompt templates. Combined turn is more like a multi-question prompt. Yeah, ultimately. So you are passing the previous questions and their generated answers as a context to the model. Okay. So model explicitly knows that these are the things which has already happened. Fine. So why do you need prompt templates? Most importantly, when your prompts become more, let's say, complex, and you want to pass variables, and there are, let's say, multiple prompts that you want to pass one by one to different models or the same model. That is where the prompt templates will start coming into picture. So think hypothetical scenario that you want to generate a report. So report generation task is what you want to achieve, let's say. So report generation about what? Let's say, so in that report generation task, let's say, that report is all about, let's say, GenAI, a simple topic I'm taking. So in that report, you want to have 3 bullet points about GenAI and then the pros and cons as a table. So here, 3 bullet points as pros, 3 bullet points as cons. Okay, some topic, whatever that topic could be. So the summary, and it will have a heading also, summary, and then comparison, something like you'll have a table summary also. Okay, so that is how the complete report you want to generate. So what does the LangChain do? LangChain will chain multiple prompts. So basically in this case, you will create one prompt to generate summary, one prompt to generate the pros, one prompt to generate the cons, and another prompt which will chain all these three together to generate the report. So ultimately you have 4 prompts, and all these prompts are in their own templates. So you have one prompt template for this, one prompt template for this, one prompt template for this, one prompt template for the entire report generation, the orchestrator, you can say. And that is where things become very interesting. And you can chain these. That's why we call it as LangChain. Okay. So you will be chaining these prompts back to back, passing these to the models. Okay. So the model's output will automatically be fed to the report generation chain. Okay. So this is one very particular example I have given, but to give simpler examples, all the prompt design patterns, prompt engineering techniques, they're all executed by using prompt templates ultimately. Okay, zero shot, few shot, chain of thought, tree of thought, all these have their own prompt templates, and that is what we are also going to learn today. Fine. And these are standard prompt templates. So all you have to do is just copy paste for your own use case. You don't have to experiment much, because I've seen that most of the prompt templates used across everyone is more or less the same. Okay, so that's pretty much standardized. Okay, for each use case. So prompt template for a particular use case, for a particular technique is more or less standardized now. So if you want to do this, this is the prompt template. If you want to do that, this is the prompt template. And that's how you just create a repo of your prompt templates and good to go. Fine. So typical structure of your prompt template would be clear instructions, what you want to achieve. Okay, some context of the previous task that has already been done, the actual input from the user, the exact specific prompt, which also specifies the tasks, and finally the output indicator, how you want the model to respond to that. Okay, so that this output can be chained to the next step.
So that's all for today's video. We have covered how LangChain helps you handle raw AI model outputs and turn them into structured, actionable insights, making it much easier to build scalable systems. I also hope you remember the free masterclass I have mentioned earlier. In that masterclass, our experts will guide you through a proven 3-step framework to land a high-paying job in AI/ML, GenAI, data science, and Agentic AI. So don't miss this opportunity. Register through the link given in the description below. And before you go, make sure to check out our other videos on AI and machine learning. There's plenty more content to help you stay ahead in your AI journey. So thanks for watching, and I'll see you in the next video.